navigate through uncertainty and make educated guesses. For instance, when an AI evaluates the likelihood of rain tomorrow, it uses probability to assess various atmospheric data points. Moving deeper, statistical methods such as regression analysis come into play, particularly in machine learning. Regression analysis helps in understanding relationships between variables and forecasting future trends. By analyzing historical data, AI can predict everything from stock market trends to consumer behavior. Moreover, these statistical insights are crucial when training AI models. They enable the models to learn from past data, refining their algorithms to make increasingly accurate predictions. This iterative learning process is what makes AI seem almost intuitive. Thus, probability and statistics are essential for AI to predict and make informed decisions. We've seen how essential linear algebra, probability, and statistics are to the backbone of AI. These are not just abstract concepts, but the very tools that power algorithms and systems making decisions based on data. Linear algebra, with its matrices and vectors, helps in data representation and transformations, essential for neural networks and machine learning models. Probability and statistics, on the other hand, are indispensable for understanding data distributions and making predictions under uncertainty. To truly harness the power of AI, diving deep into these mathematical fields can provide a significant edge. Whether you're developing algorithms, optimizing machine learning models, or simply trying to understand AI technology, these skills are foundational. For those keen on mastering these areas, a variety of resources are available. Online courses, textbooks, and tutorials are great starting points. Engaging with community forums or study groups can also enhance understanding and application. Master these mathematical domains, and you're not just learning math. You're learning to shape the future with AI.